Good morning, ladies and gentlemen. I am Will Blanton, and I am doing a project for Dr. Hubing's ECE-470 Vehicle Electronics class. So my project is on the feasibility of IR distance sensors. Now, to show you my setup real quick, I have a simple IR distance sensor, which has the receiver and transmitter in one package. That is connected to the Arduino board via the red cable being 5 volts plus, ground is the black cable, and the yellow cable is the data cable. Now the Arduino board is powered from the USB cable connected to my computer. It is also sending the signal to be displayed on the screen, showing the distance that it is from the object. It's 15 inches. Double check that. Roughly 5 inches. So 20 inches minus 5 gives you 15 inches. So this is my car per se for the project, and this will be another obstacle, possibly another car. Now it's wrapped in white because white seemed to give the best results for the IR distance sensor compared to other colors. Now, the first step to my project was to characterize the distance sensor, which I've shown here. We have at a known distance, it gives a certain voltage output, and that is characterized in the graph, and then we have an equation of the trend line, which is then put into the Arduino code, which will convert the raw data coming from the IR distance sensor, which is in just raw voltage output, convert it to a distance that we can read, and is then displayed on the right over here, just 15 inches. So just to prove that it works, let's scoot this in a little closer to, let's say, 10 inches. Solid 10 inches. We said it's 10 inches. 20 inches minus 10 should give us 10. Double check that. It's outputting 10 inches on the screen. It's exactly what we would think. Now, one thing I've noticed about IR sensors is that ambient light can have an effect on them. I've done other projects in the past where light has been a big issue. Now, just to prove that under ideal circumstances, light is not always a big issue, I have my phone with a flashlight app on it. Let's pretend this is a vehicle that has its headlights on shining into the IR distance sensor. So it should be displaying 10 inches. Let's double check to make sure it is. And yes, it is still displaying 10 inches, which is exactly what we would expect. So ambient light doesn't necessarily, let's say headlights, for example, won't necessarily affect the IR distance sensor. Now I'm sure there are examples where we can get it to affect it, but under this ideal circumstance, it worked fine. Now, one possibility this could have, or one use that this could have in the real world is for autonomous vehicles, placing these sensors all around the outside of the vehicle to become the car's eyes, per se. So if a car is beside you, your vehicle will not try to change lanes into that vehicle because it will know it's there. Then there are many other aspects of this. Now, one big advantage this has over acoustic sensors is that acoustic sensors usually can't be used at higher speeds due to the road noise that will affect the sensor and give you false data. And this can be used at high speeds. And, well, thank you very much. Have a great day.